So I started number 47 by identifying the amplitude and the period. So amplitude is 1 because the coefficient here is 1, and then the period is 2 pi over b. b is 1/2. This is saying that it's 1/2 times x. Okay, so this could be written like this too. That's the same thing. So you end up with a period of 4 pi. So with cosine, remember cosine, think like that. So the zeros are 1/4 and 3/4 of the period. Maximum is beginning and end. Minimum is in the middle. And then for the next period, this would be the 1/4 and 3/4. This is the beginning, which is already there, and then the end, and then the minimum. And just connect the points. Okay, that's it. So 49, you have amplitude 8. The negative in front of the 8 tells you that there's going to be a reflection over the x-axis. The period is 2 pi, and then it's going to shift to the left pi units. Okay, so I'm going to draw the shift to the left with this yellow dotted line. And it's still going to take 4 tick marks to complete a period. So right here, this would be the end of the period, and then the next period would be 1, 2, right here at 3. Okay, so here I have, in between the yellow lines will be the 2 periods. Okay, so cosine with the reflection, well, first let's do the zeros. The zeros would be this, since negative pi is the beginning, this would be the 1/4 of the way and 3/4 of the way. The maximum is beginning and end, but then there's a reflection, so that makes that the lowest point. And then the minimum is in the middle, but because of the reflection, it's actually a maximum. For the next period, the same thing. At 1.5 pi, you have the zeros, 2.5 pi, the other zeros. Beginning and end will be the lowest points because of the reflection. And at 2 pi, which is the middle of the period, it's going to be up at positive 8 again because of the reflection. And so you connect the points. And that's it right there. For 55, the amplitude is 2/3. Again, that's a coefficient right here. What I did here is I factored out the 1/2 from both of these. So I took it out so that it's easier to see the horizontal translation like that. Or you could just set this equal to 0 and solve for x, and you will get this either way. Okay, for the period I took 2 pi over 1/2, so I got 4 pi. So, oh yeah, and there's a phase, like it said, phase shift to the right, pi over 2, or horizontal translation. So notice that every tick mark is pi, so that means halfway down is going to be where the translation, so I'm going to draw these lines just to help. And then instead of 4 pi, I'm going to move it at 4.5 pi, because it has to be 4 pi for the period, right? So if I move the y-axis over, I have to move everything after that. And instead of 8 pi, it's going to end at 8.5 pi. Okay, that will complete the second period. Okay, so now it's cosine. The amplitude is 2/3. So half, the 1/4 of the way would be right here, and the 3/4 of the way would be right here. The maximum would be 2/3, so that's about, it's here and here. The minimum would be between 2 pi and 3 pi here, and then 1/4 of the next period, 3/4 of the next period. The other maximum would be right here, and then the minimum would be between 6 pi, 7 pi, right here. Connect your points. And you're done. Okay, so here's the graph ready for graphing. I mean the equation. So y equals -4 plus 5 cosine pi t over 12. The amplitude is 5. We get that from here. The period is 24. We get that by taking the b value, which is pi over 12, putting it down here and simplifying. Okay, here's the work. And then this means that it's going to go translate 4 units down. Okay, so then I'm going to draw the horizontal line on y equals -4, just to help when we're graphing. This is a cosine graph, so it has its zeros at 1/4 and 3/4. So that would be right here and here. Maximum at beginning and end, so from the yellow line up 5 units up, I would land at 0, 1 and at 12, 1. The minimum is in the middle, which would be at 6, and you go from the yellow line 5 units down, so you end up at -9. So right here. Okay, and then the next 1/4 of the way and 3/4 of the way. And then at 24 you go at +1, and at 18 you go at -9. Okay, so that's right here. Connect the points, and you are almost done. Okay, and there it is. So 63 has amplitude of 2 with a reflection because of the negative right here. So it's going to reflect over the x-axis. The period is 2 pi over 4 because this is a 4. And so you end up getting pi over 2 as the period. The horizontal translation is, what I did again is I factored out the 4 from both of these, and I ended up with this. So it's going to be pi over 4 to the left. So I'm going to go ahead and draw pi over 4. Okay, and it's still going to be 4 sections for a complete period, so you count, and the one on the right ends up right here. And then another 1, 2, 3. I'm probably going to do 1, 2, 3, and 1 right here. I'll label the x in a minute. Okay, so those are 2 complete periods. So for sine, the zeros are beginning, middle, and end. So here's the middle of the next one and the end of the second one. Normally the maximum isn't 1/4 of the way, but because of the reflection, it's going to be a minimum. And then 3/4 of the way you have a minimum, but because of the reflection, it becomes a maximum. And the same thing happens on the next period. So this is going to be a minimum, and this is going to be a maximum because of the reflection. And that's it. Whoops, kind of crooked. And there it is. So let me walk you through how we're going to manipulate this number 67. This is the first time we encounter, or you guys encounter, a problem with a negative x. So let me see. First, we are going to factor out the 2 from the argument. So 5 sine, and I'm going to factor out the 2. So that's going to leave me with pi over 2 minus x plus 10. Okay, I'm going to factor out the negative from the x. I'm going to factor it out, and it's going to look like this: 5 sine 2, and it's going to look like this: x minus pi over 2 plus 10. Now, if you remember the even and odd identities, that I'll put it here on this. I'll put it here on the bottom, and then I'll just remember that sine of negative theta equals negative sine of theta. Okay, so I'm going to use that here. This negative right here is going to come out to the front, because for sine that's what happens. So we're going to have negative 5 sine of 2x minus pi over 2 plus 10. So this is the one we're going to graph. Okay, so it's going to have, so this equation that I enclosed is the same as this one right here, as the original. So it's going to be a 5 with a reflection. The period is 2 pi over 2, which is pi. vertical translation is going to be 10 up. Horizontal translation is going to be pi over 2 to the right. Okay, so let me go ahead and draw the horizontal data line. And then pi over 2 to the right, so here is, okay. And for sine, let me just draw the other one. So if this is, it could be 1, 2, 3, 4, at 3 pi over 2, I have the other, the end of the period, and then 2, 3, 4, at 5 pi over 2, I have the end of the second period. Okay, so for sine, the zeros are beginning, middle, and end. So that would be here for the second period right there. Sine is normally 1/4 of the way, but a maximum, but because of the reflection, it's going to end up right here. And at 5 pi over 4, we're going to have the maximum. It would be right here. And then at 7 pi over 4, we're going to have the minimum because of the reflection. Normally, it's the other way around. And at 9 pi over 4, we're going to have the maximum. Okay? So, oops. Here are 2 full periods. Oops, sorry about the crooked. There it is. Okay, so if you wanted to extend to the left, this is how it would go. Like that. Okay, so 89, we have g of x moves to the left 2 pi units, but remember these graphs go on forever, right? So if I were to extend it, it would go right over f of x. So it talks about translating it one whole period. I know it says to the right, but that's irrelevant. It does translate it one whole period, so both graphs are the same. Both equations give you the same graph, so this would be true. Alright, so the period for number 90, you put 2 pi over b, which means 2 pi times 10 over 3, and simplify that, 20 pi over 3, so it is true. Number 91 is false because the amplitude for the first one is 1/2, the amplitude for the second one is 1, and it's not true that 1/2 is twice as big as 1, it's the other way around. Okay, so this is false. Okay, so here are the graphs of both the cosine and the sine functions, and as you can see they are a reflection over the x-axis of each other, so that would be true. Alright, so I'm going to eliminate the ones that do not work, and then I'll see by process of elimination. So right off the bat, we see that E is not going to work because the amplitude is not, is 1 on E, and it's actually 4. And there's no vertical translation. The other one that I'm going to cross out is B, because the period here tells you that the period is pi over 2, and that's not the case for this one. Then that leaves the other one. So for A, that means that you translate it to the left pi units, so that would be like right here, and that it's a 4 cosine. That makes sense, right? It's positive 4, and then it continues. So it looks like it's going to be this one, but let's just check the other ones real quick. Sine, this means that it moves it to the right pi unit, so that would be right here. And it's not a sine function, right? Because if it were a sine at here, this is where you'd have the 0, 0, and then it'd go up from here. So yeah, we can eliminate this one. And then the last one, well, it's not a negative 4 because we saw that on the left side, it doesn't start on the bottom, it starts on the top. So this one is eliminated. So the answer is A.